Okay, now we want to take a look at a couple applications using linear models, and in this segment I'm going to focus on percent type problems. This first one just says the average salary of a landscape architect is $80,000, this is federal, $80,830 per year. That is 38.5% higher than or more than that of a private sector architect. Our job is to find the salary of the private sector architect. Okay, so what I'm looking for is going to be my X. We always use that question or directive to figure out what our variable is. So I'm going to write that down so I remember when I find X what I just found. X is my private salary. Okay, now what I know, if I take kind of the sentence here, says this, meaning the federal salary is, that was going to translate into an equals 38.5% higher than the private. Okay, so that means it's going to take the private salary and add 38.5% of that salary again to it. Okay, so when I turn that into a mathematical equation, my federal, I replace that by the $80,830 is my equals. What's the private salary to start with? I don't know. I'm calling it X. I'm going to take my X and I'm going to add 38.5% of it again to itself. So to show percent of something, of means multiply, I'm going to add 0.385x. When I combine these like terms, there's really a 1 in front of this x. That becomes 1.385x. Divide through, and we find out that our private sector salary would be about $58,361 and a penny. All right, a formula that we often use in some linear equations is simple interest. And I'm sure you've seen this before. I equals PERT. That's my way of remembering it. Interest is equal to principal, which is the original amount borrowed, or the original amount invested. My rate, of course, is going to be my percentage, but we're going to express it as a decimal. And T is our time, and we always express that in terms of years. So if they tell you something about 6 months, you're going to need to use a half or a 0.5 there. You can't use the 6. All right, real simple, straightforward example first to start with. It says Louise borrowed some money at 4% simple interest for 1 year. She paid a total of $23.40. How much did she originally borrow? Okay, well remember, this is kind of common sense, but you know that when you borrow money, you pay back what you originally borrowed plus the interest, right? So the total is going to be the original, the principal, plus whatever interest she had to pay. So the total was the $23.40. That needs to equal our original, which we're calling P for principal. And then the interest. Well, how do I calculate the interest? I take that P again, times my rate, 4%, move the decimal over 2, get 0.04, and my time, 1 year. Combining our like terms, this is a 1p plus 0.04p gives me 1.04p. Divide both sides through by 1.04, and we find out that originally she borrowed $22.50. All right, this last one is going to involve the simple interest formula again, but it's a little bit more complex because we're involving two different accounts. So Jared has 2 student loans, and the total of those loans is $12,000. So it's spread between 2 accounts. The first one, it says, is 5% interest. The other is 8%. All right, so I took my $12,000 here, drew an arrow this way and that way. One goes, part of it's coming from the 5% loan, part of it he got from an 8% loan. Right? Do I know how much is in either one? No. So I can only use one variable with these linear equations. Let's call this 5% account. Let's say the principal here, the amount borrowed was X. Okay, I don't know how much that is, but I'm going to call it X. Well, then how much is in the 8% account? Well, if I started with 12,000 and I used X, I would take 12,000 minus the X, and that will tell me how much is left over here for the 8% account. So we're going to use this 12,000 minus X to represent the principal in this second 8% account. Okay, let's keep reading. It says after 1 year, Jared owes $750 in interest. Well, that's going to be the interest between both of those accounts, and our job is to figure out how much is in each of those loans. All right, well, our interest, that formula again was PRT. So the P is the principal. How much did we borrow from the 5%? We don't know, but we're representing it with an X, so that's our P. What's the rate? Well, you just turn this percentage into a decimal, 0.05, and we know the length of time is a year. But that's going to have more added to it because he's also got this other account. So our principal here, how much should we borrow? Again, we don't know specifically, but we're representing it with this 12,000 minus X expression. So that's the principal in that second 8% account. The rate, we're going to turn the percentage into a decimal, 0.08. Again, it's for a year. So I'm going to add those two things together, and that's going to be my total of $750. Simplifying these expressions here, this first one very easy, 0.05x. Here, we're going to distribute the 0.08, and you should get 960 minus 0.08x, okay, equals 750. And then scrolling down, we're going to collect our like terms, move the 960 over. I'm not freaking out that I have negatives, because when I divide by the negative 0.03 into the negative 210, I'm going to get a positive number, the 7,000. Now, because I've labeled this and kind of drawn out some schematics here, I look back and say, where's my X? Oh yeah, here it's the 5% account. So it's in the 5% account, we have $7,000. How much in the 8%? Well, that was 12,000 minus the 7 would leave 5,000 that we borrowed there.